right, hello. I think we are ready to start. It's nice to see such a big crowd out here today. My name is Leevi. I'm a developer at yle and also a part-time speaker. I'll be your host here tonight. I was thinking of starting this off with a Kubernetes joke, so let's try. Here we go. Why did the container break up with Kubernetes? It needed space. It was ChatGPT, but I tried. It was okay. I have more, but I'll save them for later. A few practicalities. There's food available at the back, so there's still some left. If you want more, please go at it. All the allergies have been taken care of. Bathrooms are down to the hall, and more are in the lobby. And for those, you need someone with a yle key card, so you can get to the other bathrooms. We'll stop around 9. We have the space until then, so plenty of time. Okay, few words about yle. How many of you guys use yle services? Raise your hands. Nice, you're a great crowd. So we have Areena, yle FI app, and the yle app and the yle FI site, plus millions of users, so that's our offering. And we have around 150 people working in the digital development, making these apps and services. We have a pretty flat organization and a modern stacks, so if you're interested working with us, head on to yle.dev and fill an open application. We'd love to hear from you. Few words about our co-host, the CNCF. There's 1,543 members in the meetup group. And how many of you are here for the first time? All right, nice. It's a pretty fresh and new crowd. All right, great. So what is CNCF? It's a non-profit foundation for getting cloud native, founded in 2015. It hosts critical components of the global technology infrastructure. And CNCF also brings together the world's top developers, end users, and vendors, and runs also the largest open source developer conference. That's pretty impressive stuff. You can find out more on GitHub and Slack. I hope the links will be posted later on somewhere, or you can read them from my slides if you really want to see those. Okay, without further ado, we have our first speaker. He's our own boy, Jarno from yle. He's a software developer working in the yle DevOps team, and he's primarily focused on infrastructure automation to help the DevOps team itself. Jarno has worked over 20 years building applications and infrastructure for the web, and he's also a pretty good table tennis player. Nice. Jarno's going to talk about yle's Kubernetes journey. Please give a round of applause for Jarno. Welcome.
Yes. So, yle's Kubernetes journey. Since Leevi also mentioned about the company, I won't get into the details, but we are the Finnish broadcasting company. We have TV channels and radio channels and so on. And we have the digital services like yle.fi and Areena and so on, which is the streaming platform. And the Kubernetes journey refers to the fact that we are still on this journey. I was thinking about this earlier, and for me it would have been nice if the talk was just like we migrated from ECS to EKS with 0 problems, and that was the talk and end of the talk. But I realized that it is you, the audience, that you want it to be a nightmare. So it's more entertaining that way. But I'm here to tell that while it is an ongoing journey, we are already a success also. We are running Kubernetes in production, have been running for a couple of years already. We do monitoring and logging and all that, these sort of centralized services on Kubernetes. We have an Elastic APM cluster running on Kubernetes. It's the application performance monitoring stack. We have a RabbitMQ on Kubernetes also, which delivers untold amounts of messages too much if you ask me. So Kubernetes already yields benefits, meaning that it saves taxpayers' money. It saves your money already. And that is all I ever think about in my job. So, but the other side is that it's still ongoing, and it's surprisingly difficult, this journey. What I mean by this is that it has taken a bit longer than, I don't know, expected or hoped. I joined this team about a year ago, and the idea of going forward with more services to Kubernetes was already there, and here we are one year later, and this is the situation. I don't know if you can see, this is the migration status, but to be fair, we weren't ready a year ago, so this is much about the journey that we have had to travel. We haven't had any insurmountable technical hurdles. We have had some, but not anything that has stopped the progress. But the goal is to expand the Kubernetes usage also in our environment. This is so much so that this is how our planning meetings look like nowadays. I don't know if you know the reference to the Leon the Professional movie, and this is our team lead after the planning meeting. To get an idea who the everyone in this context is, a few words about our organization. We have DevOps teams, which is around 150 people. We have, I don't know, 30 different teams. Some of the teams work on a mobile app, and some of the teams work for backend services and so on. There's also an ops team, which I'm part of, where it could be called a cloud team or platform engineering team and so on. But like the term says, DevOps team develops and operates their services. The slogan for our teams is that if you build it, you run it. So the question is that, do we need this sort of ops team at all? Do we provide some extra value? Of course, we do some development to make reusable components with this infrastructure as code. We have Terraform, but as we know, it's difficult to do reusable components with those tools. We also manually operate things. We start servers when they go down, and we debug problems and so on. We also do some gatekeeping to keep the environments under some control. We provision users and so on. And we also offer some direct support through Slack with these cloud resources. But if this is what we do for our day job, the question is, do we provide some real value? And as a team, are we moving forward, or we're just doing the same thing over and over again? And with this, I will turn to one of my favorite books, which is the Site Reliability Engineering book by Google. The subtitle is How Google Runs Production Systems. And even though we are not Google, this book contains a lot of good ideas about automation and so on. So it has the concept of toil. The dictionary definition is something like an exhausting physical labor, or working hard and so on. But this is the feeling I get with the term, that it's like pulling the rock to the hill, and then next day the same thing. And the book has this chapter which is called Eliminating Toil, which sounds so nice to me. If we could just eliminate all toil, the workdays should look like this every day. Unfortunately, it's not just things I don't like to do, which I wish it was, but the way they define toil is that it's usually something that is manual. You click on a user interface or you type something on a command line. It's also repetitive, meaning that if it's something that you do for the first time or the second time, it's not usually toil, but when you do it the umpteenth time, then it becomes toil. It's also something that can be automated, and not everything can be automated, or at least trivially. Toil is also tactical, meaning that it's usually driven by interruptions, like alerts, for example, and it's typically reactive, not proactive. The toil work doesn't usually provide any enduring value, meaning that you fix a system back to the state that it was previously. And the idea behind this, with what the Google book says, the SRE book says, that toil naturally increases unless it's actively removed. And to remove it, we need some type of engineering. We can't just be fixing servers with manual work all over again. We have to do some engineering work to combat toil. So the idea is then that you have to increase the level of automation. This has been our slogan in our ops team for this journey. It is also surprisingly difficult, at least in this area of development. Again, you can look at the SRE book. There's the chapter about the evolution of automation at Google, which has some wisdom in it. Relevant to us is this idea that while automation is better than manual if it's applied judiciously, meaning with good judgment, the even better is to have an autonomous system which you don't have to operate at all. And the other relevant idea here is that when you develop automation, you need a platform that can be extended so that you can fill your own needs with that platform. And with this, I would say that the current system is we're doing, I guess, well with the AWS ECS, which is the container service system. But the thing with it is that how we are using it is that we are noticing that any further automation, any moving towards this goal is becoming more difficult for us. We have some operational overhead with it. It might be that nowadays it would be possible to automate the things we do semi-manually, but this is the case for us at least, and this means that it's quite wasteful on resources. And this type of extending that we want to do is becoming is close to impossible. We are at the mercy of the cloud provider, and this has led to this idea that we can use Kubernetes, and it is and has been a good match for our needs. Of course, there's the question of should we use fully managed systems that are run entirely by the cloud vendor, or should we use a more customizable system like the Kubernetes typically is? And if you ask the cloud vendors, they of course want you to use the fully managed services because they get more premium out of those, but this whole CNCF ecosystem has proven to be more appealing for us. Examples, we have been using for our production loads, the Carpenter, this node autoscaling system, and with the autoscaling primitives of Kubernetes means that we have pretty much solved our autoscaling needs so far. We haven't had to touch that part of the system pretty much at all. Of course, there's always something small to fine-tune, but it has become this mostly autonomous system. And again, this saves that taxpayers' money that you're so worried about. We have needs for third-party components like, I don't know, Elasticsearch and so on. And these we can use the ready written operators for Kubernetes also. We can also improve security, which, as we all know, is a little bit complicated for Kubernetes, but still, now that we have a new platform that people are moving to, we can establish a new baseline for the security. And here again, we have used the Kyverno, which is this open source policy engine for Kubernetes. And it provides these ways to validate that the containers that run inside the cluster are not run as root and don't have privilege escalations and not too many capabilities and so on. And as any good security product, it provides a nice baseline but allows for exceptions, which is always needed. We also can restrict the network traffic inside the clusters. We currently use network policies, which are nice in a way that they are this Kubernetes native, but they are also a little bit painful to debug. But there's now the option of using security groups that are more AWS native. But all in all, this having a better baseline for the security also provides a good foundation for threat detection, which I've argued before that it's easier to make good detections when you have a better foundation because you know what is happening inside your clusters. So after all this, we can say something about what have we actually done. I have split this into three separate phases, even though we don't have those on our roadmap. But the first phase in this sense was this internal use. Like I said, we use it for centralized services like the RabbitMQ and the Elastic APM, but we also use it for our own tools and our own services, meaning the ops team, the services and tools that we need. And this means, in other terms, that we have been eating our own dog food. This is the idea that when you actually use your own product, which in our case is the platform for our own needs, then we are dog fooding. We are testing our service, not just superficially, but actually using it. And with this, we get to experience the pain and fix the pain if there's any in our offering, so to speak. We also get to observe the benefits. We are supposing or expecting, like the auto scaling and so on. So we get to see these in action and actually see that they are true and not just dreams or hopes. So this idea of dog fooding, meaning that you actually use your own product, is, I think, useful idea especially with developer tools, because we are the ops team, but we are mostly like other developers. But with dog fooding, there's pitfalls too, because your needs will differ from your users' need. And this is especially true if you are developing, for example, end-user applications. Then your needs will be massively different from your users. And you also might get used to the minor faults in the system or the product or the service. So even though you experience the pain, you just ignore it. So I think if you can make your product so that you can use it yourself, you should do it if you don't have to force it, but don't rely on it as the only information about your service. So do user surveys and offer support and so on. So we also had a little bit of IPv6 detour. We have these company-assigned IPv4 ranges, which is because of we route some traffic back to some on-prem networks or something. So the IPv4 ranges that we get are quite limited. So we will run out of IP addresses even inside the Kubernetes cluster, because every pod gets its own IP and so on. And we did try the overlay networking, but it proved to be too much pain. We didn't enjoy that at all. So instead, we decided to go into this dual stack world where we have IPv4 and IPv6. And there's an upcoming blog post about this transition, which is, I think, supposed to be ready soon, at least. So you can read it on, I don't know, AWS blog site or something. I don't understand all the details about the networking, but you can look it there. Just to say that I don't think there was anything specific to Kubernetes that proved to be difficult. It was mostly about the world not being ready for IPv6 yet. So the phase 2 was this paving the way for the teams. So as we all know, every team's backlog is already full of other things. They have to develop features and fix bugs and so on. And our backlog was also full of things to do, so it was a little bit of a dilemma. And the current system, the container platform that we use, in the sense works too well, meaning that if it was a complete mess and dumpster fire, it would be easier to motivate the teams to migrate. But now that it works for them, it's difficult to motivate them to move to the new platform. So we did have to make things to make the migration easier. Like I said, this idea of dog fooding using our own product has helped the coming migrations for the teams. Of course, we did some development and we wrote some documentations, which is this depressing walls of text, which make me sad because, well, no one likes to read documentation. Fortunately, we have this sort of secret weapon. I don't know if it's secret, but anymore. But we have this Wiley tool, as it's called. It's a command line tool called yle. It's like a if you have used, for example, TerraGrant, it's a wraps Terraform and other these sort of CLI tools. And it's written in Golang, and it's a single file binary, and of course it has a function to update itself, so we can get new features of the tool to the users easily. And it is the primary interface for every developer, every team to operate these cloud resources. So this means that we can build stuff, make the life easier with the Yle tool. So we can do things like this. We have the Yle init Terraform, which you can choose the project type and give the details about your applications, whether it needs load balancers, or if it's a public service, how many gigabytes of memory it needs, and so on, and it generates the Terraform configuration for your application, and we can make sure that the Terraform configurations are correct, hopefully. And once we've done this, we could provision these cloud resources. In this case, it's this sort of application module that you would apply from a different location with a different command. But this is the idea. Yes. And with this tool, we can provide the utilities and other helpers for the developers, and we can keep them updated, because not all developers need to install all of the stuff on their own computers. We provide them inside a Docker image. And finally, the deployment of apps, we can make it keep it the same for the developers, so it makes it a little bit easier. And yeah, the docs would be even more depressing. It would be 10 times longer, so at least a little bit easier for the developers. So finally, we are rolling this platform to wider audience, and as we know, no plan survives the contact with the users. Meaning that however long we try to pave the way for the users, the actual migrations will surface new problems. My favorite one, well, the reason for that is that they're not written from the scratch. They are written for the old platform, so they have quirks about the old platform. One of my favorite examples of this was this one application that I think it tried to use some AWS APIs, and this was all we got out of the application, and it turned out that it didn't have some library and so on, but this is the reality when you actually migrate the DevOps team's applications. And it turns out the test driving the docs is also difficult or impossible. The first application which started to migrate, I think we made like dozens of fixes and improvements to the docs, even though I tried to be really accurate about the docs. So the lesson for me is that we shouldn't over-prepare this sort of migration, because then it would have taken another year to make the preparation, and just be prepared to be a little ashamed that not all is ready. So all in all, not a nightmare. Sorry to disappoint you. It's an ongoing journey, like I said. We have just started this with the teams, and I think we've done pretty well with the limited effective time. Even though it has taken a year, we have other things on our plate, so I think we have done well. So that's the end of the talk. So thank you. And if you have any comments or questions, you can ask. Thank you.
All right, there, I'll pass the mic.
So thank you for the talk. I had a question. Did you mention 3 phases?
Yes.
Because you only showed 2 phases. Is that the one missing? That's the first question. And the second one is related to the phase 2.
Yeah.
And so you were talking about presenting all development teams as DevOps teams. So you build it, you run it.
Yes.
But I was wondering, what are the other changes? You're going to keep the tool the same,
Yes.
but what are the other changes that will affect the developer as they transition to Kubernetes? So those are my 2 questions.
Yes, the first phase was the internal use. The second phase was the paving the way for the users, preparing for and the final phase was the actual migrations. But the question was that what changed for the DevOps teams, you mean? Yeah, well, nothing big changed, and we tried to make it so that as little changes as possible. So they are running containers, and they are just trying to make them run on Kubernetes with the new baseline and so on. So nothing big changes. But when you're running as a DevOps team, the production already, you don't want to do anything to, change the current system because it's too painful and difficult. You want to just keep running the old system.
All right, any more questions? There. Yes.
Yeah, thank you for the presentation. Yeah, and then one question came up. So actually, I have a couple of questions. So one question is, what is the main motivation behind like a migration if it's already working fine? Is it just following the crowd, following the market?
Yeah. Yeah. The main motivation is actually the money. The current system is a little bit wasteful on resources, and the experience that we have had with the new system and with the Carpenter and auto scaling, because we have sort of little bit special needs because the events that we serve demand high traffic, and then we have to scale up and down and so on. So the current system is a little bit wasteful on that, and we hope and believe and have seen that the Kubernetes with the Carpenter and other tools we can scale so that we don't have any waste on the system, and we need also the extensions and so on.
Okay, so basically, do you think that going from like a current on-prem from CapEx to basically OpEx, so do you think that the money will justify like when you migrate? Because when you go to cloud, there is always egress clause and whatnot.
Yeah,
this kind of things.
We are mostly running on cloud already. We are just migrating from one container platform to another one.
Oh, okay. Okay.
And we do have big egress and ingress.
Okay, thanks.
Yes.
Yeah, so and one more. So you mentioned that your journey has started quite. It's going on. Actually, we are also on that path.
Yeah.
From on-prem, not from one cloud provider to other, but from on-premise to cloud. And yes, it takes time, of course. we also probably have the same story in some cases. So you also mentioned that there is no technical difficulties, but what exactly is now hindering you? Is because like there is too much to work in the dev team, they can't really focus?
Yeah, it's mostly because there's this inertia from the old system to the new system. So, and since we haven't automated everything, it would have taken a year or more. So now it's like it's a little bit. You have to offload some work to the teams also. They have to be prepared to do some work also. So it's not as smooth as it could be. but we need to move forward. So it's that, yeah.
Yeah, thanks.
All right, any more? There's one.
Thanks for the talk. You talked about internal use and dog fooding, and you run on AWS managed Kubernetes, right?
Yeah.
So you briefly mentioned logging and monitoring at the start, but you said you run the application performance monitoring system inside the cluster. What do you do for the actual cluster logs and monitoring and like your internal services? Do you also run those yourself, or do you use AWS provided components?
Mostly, I guess, AWS provided, yes. So the APM and those are for the needs of the developer teams mostly.
Yes. Okay.
Is that a hand? Yes. Great.
You said that you went from you did a migration. So how much it affected your deployment strategy? Have you changed it after the migration to a little bit, maybe, I don't know, but probably decrease the costs? Because for every system you have multiple environments, for dev, probably RC and production. So what changes did you face after the migration for the new system?
We are only planning those; they are not there yet. So that's we are planning to make changes to that, but we are only on the migration phase currently. Not done yet. Yes.
Okay, there in the upper corner. I think we can make this work.
Yeah,
great.
Yeah, thanks for the talk. It was excellent. More on the deployment story. You mentioned that the deployments are always in all the projects similar and so on. So how do you deploy? Is it like automated deployments on every change? And also on the CNCF stuff, do you use their stuff like Argo or Flux and such?
That is also a little bit under development. We have, I don't know, for historical reasons, we have we deploy through the tool itself. So that's manual for the teams. There's also the automated version on GitHub, but yeah, that's one of the areas that we also want to improve with the Kubernetes platform too. Yes.
Yeah. Thank you.
Thanks. Okay, there's more. Please have the mic.
When you have a new product coming, a new DevOps team, how is the experience now different for those who are starting from a clean table with your new? Does everybody start with the new system instead of the old way of working?
We haven't had any new teams at this point, but if we got some new greenfield project. Well, yeah. I should say that hasn't come up yet.
You should just answer that the experience will be much better.
Yeah, sure. It's all easy.
Okay, any more, or is that it? There's one.
Yeah, thank you for presentation. My question is, how do you work with some people who don't like this? Because sometimes when a new technology arrives to company and we do this, and sometimes people don't like, and how you negotiate with these people?
Yeah, it's a good question. I don't have a good answer, but I guess we do have. We are sort of gatekeeping the system, so we do have some say like that. Well, you must move at some point. We stop supporting the old system and so on, but we would like to be proactive and offer the sort of easy way out. But yeah, I don't have a good answer for that. I think you should find Akseli, who is. He was just asking why it's so difficult to migrate to EKA, so you can ask him.
Yeah. Because when we move to cloud, that's sometimes people don't like these because we host it on premise, we can take our data and something. But when we moved and eventually on cloud, that's after that people say, "Wow, that's easy," and we like this.
Yeah, I share the experience.
All right, I think I'm gonna time box it here. We can let Jarno off the hook. Thanks for the great questions and give a big round of applause for Jarno. And I think it should warm every taxpayer's heart what he's doing. It's important stuff.
Give him a raise.
All right, so our next speaker will be Juan Antonio Osorio from Stacklock. He's a software engineer from Mexico, living here in Finland, and he's worked in security and cloud-related open source projects such as OpenStack and Kubernetes, as well as security for bare metal environments. Exciting stuff. He's currently working at Stacklock, building tools to make software supply chain security easier and friendlier. And Juan is going to talk about how to simplify supply chain security. So please, applause for Juan.
Of course, the Linux user is struggling with the display. Here we go. Primary display. Wow.
Is it supposed to be easy now?
They said, right? Oh, that's a bit better. I probably want a mirror. There we go. All right, finally. Trying to connect. What happened? It was supposed to be easy, they said.
Also, if that doesn't work, I can put the like that.
We'll see. There we go. Yes, it worked. All right, hi everybody. So yeah, Juan Antonio Osorio, people call me Oz. It's a little bit easier. And the first thing that I want to do is thank everybody here. People usually think in the end, but in this case, like I'm very, very grateful about Cloud Native Nordics, about CNC of Finland, and Yle for hosting this. It's a great opportunity, and these events are awesome. Keep them going. Thank you so much. Now, about me, as you already heard, Mexican living in Finland. If you want to catch up after this, a lot of the stuff that I'm interested in, supply chain security, vulnerability management, I can rant for hours, so beware. But yeah, now I do work for a company, and I have to give them a little bit of spotlight as well. And the company is called Stacklock. We're fairly new. We've been here, well, around really since May of last year. So we don't have a cool story about how we migrated to the cool new technology. We were fortunate enough to start so late that we started in cool technologies already. But basically what we want to do is make it easier for you to build software in an easy and safe way, right? So we want to make a difference in open source. We want to make a difference in your developers' lives. And yeah, we're going at it. How are we doing it? We recently announced in November a couple of projects, one of them called Trusty. And the basis of Trusty is that it will allow you to get information about your dependencies, right? Is this a package that you can trust? Is this a package that's unmaintained? Or is this a package that you should be aware and away from, right? So this whole thing requires probably its own talk, which I think is really cool, the stuff that's happening in Trusty, but today is about Minder, right? And this is what I'm gonna talk about. Why did we decide to build Minder to begin with? What the hell is that? How does it work a little bit? As I stand here, I don't know why I didn't show you a recording. I'm actually gonna go live, and let's hope that production works. We'll see. And then I'm gonna talk about what's next. And since it's open source, if you wanna help, I'm gonna give you hints about it. So let's see. And so one of the first things that we encounter in supply chain in general, or with the dealings of trying to lock down your pipeline, is this really damn hard to do. There's so many things out there. There's a lot of buzzwords that, just naming a few, some of them might be a little bit easy to understand, like dependency management, but SBOM, it's a bit fuzzy. How to use it, how to generate it, how to maintain them. Now there's K-bombs, there's crypto-bombs, there's attestations, all sorts of things. So it gets pretty complicated, especially when you deal with US markets that now require such things, right? Then you start checking into the newer projects that are dealing with these things, such as, we have the OpenSSF scorecards or Sixdoor in Toto, and you start seeing slowly but surely that it's pretty hard to navigate this thing. And it's really hard to know where to start, how do I even get involved, and where's the value, right? I'm gonna invest a lot of engineering time, a lot of cycles of my developers into getting this stuff hooked up, and then I don't even know how to use it, right? So what we wanna do is make it a little bit simpler. I know there's a lot of promises in here, but we do try to make them happen, right? So Minder is an open source project that hopes to automate a lot of the settings that you would normally need to do to make your pipeline in general safer, right? So from repository configurations to best practices like branch protections and security scanning, to tracking your dependencies as well and helping you make right decisions. We have some rules as well for Minder to give you reviews about is this trustworthy or not, right? So it's expanding quite quickly. And most importantly of all, we do automated remediations, right? So as the previous presenter said, you want to avoid toil at all cost and having to keep track of, is this vulnerable? What is this dependency? What is this setting right here? Having to click your way through the GitHub UI. It's pretty tedious. It's toil, basically, which could be automated. And that's what we try to do. Another thing about Minder is that it's multi-tenant. So if you're in an instance of Minder, you can share it with other folks quite safely, and they have no idea what you're doing, which is a good thing, in my opinion. And for me, at least, very importantly, it's open source, right? So you can check the source code, you can contribute. We try to be friendly, at least, and hopefully we achieve that. So if you want to have discussions, there is already a small community forming, right? We've already gotten some external contributors from Africa, from Turkey. Mostly we're based in Europe, but yeah, it's going and it's pretty exciting. The second thing is that it's available as a service. So if you want to try that out for your personal projects and you just want to give it a spin, maybe you don't want to put your production repositories there just yet, but if you want to start playing around with it, you can do so today, right? So let's just go through some concepts of what we have today in Minder, although we're going to expand this a lot more in the future. But Minder presents the concept of providers, which is nothing new, but ultimately it's a central platform where you get a lot of information from different places, be it GitHub, be it Docker Hub, GitLab, right? And we ingest a lot of those things, put it in one place, and then start doing automation on top of that, right? So we're gonna track repositories. We auto-detect for GitHub at least artifacts that you're generating, right? So we know the graph and the map of where thing comes from. We can even do pull requests, right? So you know what pull request was part of what artifact as well. And automate, right? Which is what we all want. I'm a lazy person. I don't want to do a lot of manual work. Let's just get Minder to do it, right? So, and we do so through policies, right? If you like Kubernetes, maybe you don't. And if so, I don't know what you're doing in a CNCF event. But if you do, this is not going to look too rocket sciencey for you. It's not a CRD, but it is a YAML manifest that describes what you want to do, right? In this case, our policy engine, you create a profile, and you say, hey, I want to enable secret scanning for my repositories in general. And if you add remediations, in this case you don't, but Minder will just do it, right? We want to reconcile to the desired state. Similar to Kubernetes, nothing fancy. Similar with artifacts, right? I want my artifacts to be signed. I want them to be verified and the bundle verified as well. That's a 6-store concept. Let's not get into that just yet. But Minder should be able to help you with this kind of things as well. So this is more or less where we're going. Rules in Minder are pluggable. You can write your own. We have a repo with a bunch of rules that also a couple of folks external folks have contributed as well. So yes, I mean, we're not having any internal magic here. Everything's open source. And it might have sounded a little bit like, oh, you have repos, you have artifacts, but ultimately we want to track the whole supply chain for a specific artifact, right? From the pull request to the person that did it towards where is it running, where was it built, right? So there will be a lot of work coming for actually doing checks on build environments and actually doing checks on the workloads, right? Because ultimately you want to know, you want to have this safe and fuzzy feeling of, I know exactly what's running, I know how it was built, and I know the dependencies of that thing, right? So how does it work? We didn't build this whole thing from scratch, right? We stand in the shoulders of giants. Again, Kubernetes being a big inspiration and where we deploy this thing, but we do use a lot of other things as well, right? So we did learn a lot from Kubernetes, right? We try to be level triggered, meaning you observe a state, you want to get to that specific state regardless of the triggers that you get. We do deploy on top of Kubernetes, right? And we did that from the beginning, so we don't have a cool story about how we got into Kubernetes. We just started that way. But we try to keep state out of it, right? One thing that Kubernetes is fantastic in is making sure that you have the right state, but Kubernetes is not great when you want to have a multi-region application, for example. So that's one of the caveats that we're trying to avoid, and thus the state is in Postgres, right? Which is a boring technology, but goddamn does it work. We also are a security company, right? We don't want to track who you actually are and have some scary PII in there. So we delegate towards an identity provider. We get a hash of your user, and ultimately that's what we use. We use OpenID Connect, and we do that via Keycloak, right? We just get some of the claims of the token that you get from Google or from GitHub, and yeah, that's how we track identities, right? So that's like in Kubernetes outside of the system, right? We don't want to touch it. Your PII is safe. And finally, of course, we leverage 6-store quite a lot, right? One of the founders of the company is a founder of 6-store as well. And the whole point out of this thing is that 6-store gives you really good idea of where did something come from, gives you a lot of tooling for figuring out how was your package built, what kind of software is in it, right? So the ecosystem is thriving, and we're leveraging a lot of those tools to get that information, map that in Minder, and give you a nice view on top of it, right? So that was a very fast speed run of how things work, and I think what some folks might be interested in, how does this thing look like? Because it's all hand-wavy until you actually see it in action. And so, again, the madness of me running this actually live, hopefully the let's see. Is that phone better? Yeah.
Maybe a little more.
A little more. There we go. All right. Go. All right, so we actually have a couple of Minder instances. We have staging and production. In this case, I'm gonna hit production in hopes that it's a bit more stable. We'll see. And what we're gonna do is log in, right? That's where we start. And in my case, I had already gone here and registered my project in it. Oh, that's a little funky, but okay. Yeah, I have a project ID with my GitHub user. This is the production instance. There's nothing secret over here. And in our case, what we're gonna do is that we want to lock down and play a little bit around with a couple of repositories that I have, which is this project called Bad Python and a test repo, which are really descriptive names of what they do. One of them is in Golang, one of them is in Python. We have support for NPM, but I didn't touch it today. Before Minder can do anything with this, we need to register the repositories, right? And what we're gonna do is, well, I had already enrolled my GitHub account in Minder, right? So you can either select all of your repositories and it'll just track everything. This could be hundreds of them. In my case, it actually did handle the 200 plus repos I have. But not today, right? Today, we're just gonna do a test repo and bad Python and go. And great. So now what do I wanna do? I wanna enable branch protection for these repositories. Branch protection is basically some rules that GitHub allows you to do to protect a specific branch, right? What does that mean? If you wanna merge something into a specific branch, I want there to be code review, right? I want there to be CI already passing, right? I don't want an admin to force push to a specific branch, this kind of stuff, right? You don't want people messing with your production branch, for example, so that's what we're gonna do. And this is the profile that we're currently using, right? We enable alerts, and you'll see those in a bit. And this is a ready-to-use profile that you can just get from our open source repo. And let's see, go. I'm gonna create this profile right here. Right, it created it, and let's see how our repos did. Wow. All right, so this is not great, right? It showed a lot of failures. I don't have, indeed, any branch protection rules, which is terrible. So Minder also gives you some guidance on how you could do it in case you don't trust us to mess with your repos, which maybe you shouldn't to begin with. But let's see our alerts as well, right? I did say that there were alerts enabled, and indeed there are, right? So your security team is gonna get a whole bunch of emails about why this is an issue and how they could solve it. But anyway, this is not great. I don't wanna do toil, right? I just want Minder to solve it for me. And so let's do that. And we can do that just by changing this toggle right here. Right, so remediate on just tells Minder like, hey, go ahead, fix these issues if you can. And now it's just a matter of applying it, right? Those of you who have dealt with Kubernetes are gonna see some inspiration there as well. It's quite similar. Right, so now you can see that it applied it, and let's see how it went. Right, so we start seeing successes over here. And that basically means that Minder did his job. It already applied the remediations, right? You don't have any advisories anymore, so your security team hopefully is not being swamped with alerts anymore, because they matter too. Security people are people too. Now we actually have branch protection rules, right? Which is good. Yeah, we're checking them out. And what happens if I actually try to remove something, right? Let's say I remove this one and this one right here, save changes, and then let's see. Minder just automatically enables them again. So you can't actually disable them, it just goes and reconciles, right? So Kubernetes reconciles replicas, Minder reconciles security settings, if you wanna understand it that way, right? So yeah, it's in a good state, and let's see. What else can we do with it? We have a bunch of profiles around, and one of the things that GitHub wants you to use is GitHub Advanced Security, right? Fortunately, these projects are open source, so I can just freely use all of those features, which is fantastic. So let's give it a try. I'm gonna enable the Advanced Security profile, and what that profile does, it enables scanning for hard-coded secrets, because we don't want those in our repository. That's a bad thing, don't do it. And CodeQL, right, which is a nice little handy static analysis tool that you can use, right? So if we actually go to our pull requests, we're gonna see something that Minder did just now, right? It's configured with my user at the moment, but yeah, it just enabled a pipeline. It's already running even over here, so you don't need to submit files and have a bash script as I did in my previous job. It was fun to code, but that's not sustainable. If I would merge this, which I won't right now, you would see that the advisory would be closed, right? So we have another advisory that our poor security team would be reviewing. Let's see, secret scanning. Settings, code security, secret scanning is enabled. Let's try to disable it. Refresh, and it's back on, right? So the reconciliation already happened. Minder is just gonna keep doing it, helping you not make mistakes. Let's see, what else? Dependency updates, right? So I'm a big believer in updating fast, updating frequently. Dependabot is a great tool that allows you to do that. There's other tools like Renovate, which are a little bit more thorough, but hey, let's try Dependabot over here, right? So in our case, we can enable it for our Go repositories, and if Minder detects that your repo has Go, it'll propose a PR. Right, it could also do it for Python, right? So if you have a Python repo, you could do it as well, and we can basically support anything that Dependabot supports in this case, right? So let's see. Right, so you start seeing Dependabot over here, you start seeing Dependabot over here as well, right? So off it goes. And finally, dependencies, right? At some point, I am gonna develop my project a little more. I'm gonna start introducing new aspects to it, like request, OAuth, all sorts of things. So let's try to get this a little bit safer, right? In this case, this profile over here gives 2 checks, right? One check is gonna check for vulnerabilities in this databases. The other one is gonna check Trusty, which I already mentioned, right? Trusty has a scoring system for trust of the packages. In this case, I chose 5 just because I had to pick a number. But ultimately, 5 is medium trust, so to say. If we want to get into trust scoring, we can talk a lot more about it later. But let's save this. Let's create the profile. Off it goes, and let's give it a go. Right, so now in bad Python, let's say that I'm coding something that needs REST API, right? So I'm probably gonna need requests. If anybody of you have done Python, that's a fairly common package. Let's check our requirements. Edit this in the browser like a savage, and commit these changes. Create a pull request, and off we go. All right, so now Minder is gonna detect that there's a new change in the repo, and it already told me like, hey dude, this is terrible. You have a vulnerability in this version that you try to use. Why don't you use this one instead? And I can just commit the suggestion, and I'm better off, right? So also the trusty check decided that this package is safe to use, right? So because it doesn't have a low score, requests is a fairly common package. We know the provenance, we know where it came from, we know it has high activity, so it's probably just fine to use, right? So this is great. Minder already was useful in this case. Let's do something else, right? So let's say that now we need to communicate with an OAuth server, right? Or we need to have some OAuth flow in our application. And so let's try to look for a library right here. So Python OAuth 2. There's a couple of blog posts. No, these are promoted. No, these are blog posts. All right. And from PyPy, we can see the first hit, right? So the first hit tells me that this Python OAuth 2 should be good, according to Google. Let's see how this went. Again, let's do some savagery. Commit the changes. Create the pull request and create it. And so let's see. In this case, oh, there we go. Right, so there was a package with a low score, so Trusty is trying to warn me not to use this one. For another package, it will normally suggest you some alternatives, but in this case, it didn't quite detect some. So let's see what actually happened here. Trusty package.dev. It was Python OAuth 2. Demo effect. Yes, finally. I was worried it wasn't going to happen. There we go. Right, and so it turns out that this is a deprecated package, right? So it has a score of 4.8. So I probably should not use that. Why is it a 4.8? Because repo activity is very low. We do have ways of detecting if something is marked as deprecated as well. I'm not sure if this is showing the UI right now, but the author is probably fine. This is not a victim of typo squatting attacks, and we can establish the provenance, so we can very certainly make sure that this comes from where it says it comes from, but you still don't want to use a deprecated package, right? That's just going to bring you into situations where there's a vulnerability that's not going to get fixed. And so this is the type of thing that we try to help you understand a bit better and not fall into. Of course, we could have done a bit better job at telling you in the Minder side, and we will. But that's what we're currently at right now. And yeah, that's all for the demo. It actually worked. Wow, what the hell? Woo! We actually do have the team monitoring right now because they knew I was going to give this talk. So maybe they're panicking right now if I check Slack. We'll see. But all right, so what's next, right? So we're going to write a lot more rules. You saw some of the rules, but we do have more actually in the repo, like scanning for stuff with Trivi, for instance. We have a rule for that. But hey, I mean, a security tool is only as good as its content, and that's where we're going to put a lot of focus. We're going to get a shiny UI for Minder, right? So that's currently on the works. You saw a command line. Command lines are cool for some people. Not everybody likes it. And so we're going to cater for those folks that don't and give you a little bit more statistics, which a lot of people like. Next as well is build environment attestations, right? We want to make sure that if you're building something, it's built somewhere safe, right? What do I mean by that? So you might be using GitHub Actions to do your builds, but you might be using Jenkins or Tekton or a Kubernetes cluster. And we want to make sure that those clusters or those environments are safe, right? So that information is going to go straight to Minder, and we're going to give you some scoring based on that as well, right? Or even a little bit more monitoring. We're going to do workload mapping too, right? So now that we have a link between the package and where it came from, we want you to have tools to make sure that you're deploying what you think you're deploying, right? So if a package, let's say a container in Kubernetes, is not signed in Sigstore and it doesn't have a package that is actually tracked by your repo, then you might beware, right? Because you're not deploying what you think you were deploying. So that's the kind of things that we want to track. And that is on the fly right now. We are working on something a little bit weird called hierarchical multi-tenancy. And the idea is that right now you have a project where you register your repos and your artifacts and so on. But that's not great for an organization, right? If you have a bigger team, you want to enable fine-grained access to those teams, to their information and their repos. So that could be done with a hierarchy, basically, a project hierarchy. So you could have yle, and then you would have the yle DevOps team and the yle security team with different access between the hierarchy. So that's something that I'm currently working right now. And along those lines, an OpenFGA-based authorization engine, right? Because we're a new company, we get to pick all the cool, nice technology. And I personally love OpenFGA. I'm super psyched about his talk, actually. So yeah, we're gonna take it into use and give it a spin. Again, super excited. I've worked in open source for many, many years, and I don't want that to change. And so Minder is open source, right? Please check it out. Stars or code reviews or complaints like, this sucks. Well, I appreciate that too. There's a production instance, so try it out. We have 2 instances. If you build the CLI yourself, you get to staging, right? Because you're testing. If you download from our official releases, you go to production, right? So just so you know. And give us feedback, right? We have a Discord server. We are fairly active there, and so we really appreciate when people come to us with questions or proposals. And yeah, if you wanna if you have time for coding or you have time for helping us in the documentation, please go ahead. We love contributions. We're not like SQLite. And finally, if you have a smartphone and you want to check those out, I'm giving you nice and fancy links so you can actually check those out. So thanks a lot, and I think it's time for questions.
It is indeed. Thanks for the great talk, and just raise a hand, I'll pass the mic. All right.
Okay, so a question from YouTube. Does Minder do vulnerability scanning for containers like Trivi or Terraform scanning like TFSec?
So one of the things that we're trying to do is not build yet another scanner. We might get there at some point, but we instead take the approach of there's already a lot of great tools out there. Like I personally am a big fan of Trivi, for instance. And so we just help you find those and enable those in your environments instead, right? So we try to work with, for example, same as Nick or TerraScan and Trivi. We'll just give you a policy that you can enable it, make sure that it's there, scan the results, and you have visibility.
Okay, here.
Yeah, thanks for the talk. I will definitely be using Minder.
Hopefully.
Now a bit self-referential question, because it seems that Minder has quite far-reaching permissions to your repositories to do all kinds of stuff. Can you track Minder as a part of your supply chain with Minder? Or should I have another Minder that tracks that Minder?
Oh, recursive Minder, I would love that. Yes, so this is not the first time that this question comes up, right? We actually have a question that came up in the community when we just open sourced it with the same thing. Unfortunately, Minder does require a lot of permissions. We are working to try to scope those down and figure out better solutions for managing those permissions. What I personally would like in the future is to have a Minder monitor that tracks from the GitHub or GitLab audit logs everything that Minder does and make sure that it matches, right? But we're not there yet, right? So if you want to help out, I would love to pair with you on that one, because yes, it's a concern for me too.
That's awesome. Thank you.
Okay, yeah.
I'll ask quickly again, since I'm close to the mic. So, what is the monetization plan? I did not find a pricing list on your website yet. I know that you got a lot of investment money recently and so on. So, how does that work?
Right. So we are planning on offering Minder as a service, right? So if it's free for open source, and part of our goal as a company is to make open source dependencies safer, right? So if you're an open source maintainer, use it for free. You'll get all the fancy cool features from Minder. But if you're an organization, it is going to be a paid feature to have private repositories, for instance. We are still working on having a bit more thorough monetization strategy, but that's part of it, right? Minder as a service and Minder Enterprise, for example. So that's one.
Thank you.
And thanks for the mic. Do we have any more questions here?
Do you plan to have Gerrit support?
Garrett?
Yes.
It depends on the market. So some of the folks from the company are ex-Google, so yes, they've brought up like, hey, I'd love to have Gerrit support, right? They know the REST API very well. But it really depends on what people ask for, right? So far, I know that folks are interested in Bitbucket and GitLab, so probably those would come first. But again, we do have a provider interface. If people are interested in Gerrit, they're more than welcome to contribute, else we're going to see where it lands in the pipeline.
Okay, thanks. Well, I would hold the mic for another question. I see that there are lots of overlaps with the OpenSSF scorecard in the things what you are checking.
Yes.
So are you using the scorecard itself, or did you re-implement some of the checks, what it's doing?
We re-implemented a bunch of the checks, right?
And
so we did look into the scorecard piece, but it didn't seem extendable enough for what we wanted to do. And it just turned out that our policy engine could very easily implement a lot of the things that they do as well. But again, I mean, we talk to that community too, and if they come up with a check or we come up with a check, we'd be more than happy to contribute and talk.
Okay, thanks.
Yeah.
Right, let's make this the last one, so make it count.
Right. Yeah, so does Minder like check what kind of GitHub actions, like if you can use some external parties reusable actions? And I think that's part of the supply chain security in CI/CD. So does it check if you're using something that's potentially malicious?
That's actually in progress. But yes, I mean, it has been one of the big concerns that we have, GitHub Action security, right? And the fact of the matter is that GitHub Actions, I love them because they're so easy, but I'm terrified of them because they give you so many ways to shoot yourself in the foot. One of the things is that floating tags are very easy to fake. And so we actually created a very simple tool for you to replace tags with hashes automatically with Minder. I didn't show that off, but that project is called Frisbee. It's like a library that does that. We do that for containers too. But there's a couple of things where we're actively working to get in a better state. One of them is going to be GitHub Action permissions, right? Because right now you can just give it all of the permissions that you could ever want in an action, and it'll get a lot of scary things from your repo. And then the second one is this action trustworthy at all or not? And that's going to come in Trusty. So we'll get there.
Thank you.
All right, I think that's it for the Q&A, so give a big round of applause for Juan.
Thanks, everybody.
In 47, if that makes any sense. See you then. meetups in Finland, co-created Cloud Native Nordics and has spoken at 8 KubeCons, including delivering a keynote with Nikita Raghunath. I think I butchered that one. Recently, Lukas wrote his bachelor thesis on cloud native principles. Interesting stuff. So Lukas is going to talk about implementing relation-based access control for Kubernetes. Please give a big round of applause for Lukas.
Thank you very much. Thank you very much, and thanks for coming to this meetup as always. Good to see so many of you here. Also, shout out to Gergely and our other co-organizers, Annie, Erno, and Mariam. Great. So let's do this one. I'm gonna present a talk here that I presented in Chicago a couple of months back now, and a topic that I researched quite a lot during the last fall. As I said, like I've been doing quite a lot of open source for a while, same as us. Very nice to kind of be part of this community, share experiences and kind of grow together when we see what works and what doesn't. This topic kind of came to my mind last KubeCon actually in Amsterdam, not last KubeCon, but last KubeCon before, which was Amsterdam, so in EU. Also shout out, you should definitely come to KubeCon Paris, which is in mid of March. You better book your tickets. Now, by the way, is there anyone coming? Hands up. Perfect, nice. We'll try to put together some kind of group or something, I don't know. We all have too many, how to say, messaging groups in all kinds of media these days, but it would be fun to kind of catch up there as well. Yeah, so the idea came along around a year ago because when working on the Kubernetes project, there's a lot of APIs these days. There's a lot of resources, and there's more and more of them all the time, thanks to Kubernetes' fantastic flexibility and accessibility. This induces some problems in practice. So one of the nice things, nice quotes I like, I don't know who said it, but the only difference between theory and practice, or in theory and practice are the same, but not in practice. So that is what this is kind of meant to resolve. How do we do in practice such fine-grained rules such that we can lock things down in a necessary amount while keeping things extensible enough. So also kind of nice to get a shout out from us for this, like probably we'll talk more about this one. So that's the intro. That's a kind of context from where I'm coming with this. I then at KubeCon a year ago, I was speaking to the maintainers of OpenFGA. OpenFGA is one of the projects that are open source that are inspired by Google Zanzibar, a white paper from Google in 2019, where they describe how they do all of their authorization at Google. Then speaking with them, it's a CNCF project. We said, okay, let's put a, make a talk together. And yes, as said, Jonathan Whittaker was co-presenting with me in the real version of this talk. So we did. We put our minds together and came up with a way to secure the Kubernetes API surface of Kubernetes or similar technologies through the use of this OpenFGA relation-based access control engine. So we'll go through that. What is it? How can we model this? And I can't do a demo, unfortunately, because my computer is there streaming this to YouTube. But I'll show the GitHub repo in which I put all of the documentation and all of the steps there. And then we'll talk about what comes next. Hopefully you'll be a part of that. So what is OpenFGA? It's, well, FGA stands for fine-grained authorization. Zanzibar I already mentioned. The core idea is that instead of modeling like having very fixed things like role-based access control, we have already from the system fixed that we need to have roles. That's one type, and we need to have users. That's one type, and we need to have some other things that is arbitrarily defined by the person that kind of made that authorization system up, right? So they enforce some kind of opinions on how you should structure your authorization, and because they put opinions into that authorization system themselves, it's not general purpose enough for most organizations once they grow bigger, right? So Google had another approach by modeling the whole authorization state as a graph. So nodes and edges. I'll have lots of visualizations here. Nodes and edges, because that's a very generic data type, and you can do a lot. And in fact, they are running all of the Google Drive, YouTube, Maps, whatever, Gmail, in the same graph. So all the data you have, every time you click, that request access on Google Docs, that goes into that graph, which is globally kind of distributed using their Google Spanner. So that's the context. Every time Google, makes a white paper about something, open source projects, flourish. So Kubernetes is one of those. OpenFGA and Zanzibar is no different. There are a couple of these. OpenFGA is for now the only one that is in part of the Cloud Native Computing Foundation kind of umbrella organization for now. So there's good community, and you can join them as well. So what does this more like in concrete terms look like? So say you're an app developer. You want to specify, you're managing an app, you want to specify naturally some authorization model. Users can view folders, folders have documents. It's one such model. Fair enough. Then you make a UI, you have all that kind of stuff, you have users, and then I am a user and I go and create a folder called customers, so I should be able to view that. And then I create a new file in that folder called secret. Okay, this data is now, that is different from the model. Now this is concrete data. And that data needs to be stored in a database as well. But then when it's stored in a database, you can ask, can Lucas view this document secret? Yes, I should. But then we can also do, and that's kind of the simple query, but then we can do the reverse query. What are all the secrets, documents I can access? There's lots of good tooling. There's a domain-specific language for providing the declarative authorization model. So like, how do you model this graph? Again, you don't have to kind of comply by anyone else's role. This is a role, this is a policy, this is a user type. You can make those completely yourself. And there's SDKs for multiple languages. You can deploy it in different ways, embed it as a library in Go, deploy it as a sidecar service, for example, or then as a completely normal standalone service with its own database and all the things scalable, like all of these things we are talking Kubernetes is so great for. And then you access it through gRPC or HTTP. Fair enough. Okay, so let's talk about the model. So we have types. They are modeled in the graph as nodes. So user type and document type. And then relation between these. Here we have two possible relations between user Lucas and document secret. Read and delete, for example. Those are two possible ways that could be in this graph where we have defined that we have user type, document type, read relation between these two types, and delete relation between these types. Then in order to make any concrete instance of this, we create a tuple, so a relationship tuple. So we say that this is the source node, here's the destination node, and here is through this relation I will access. Oh, great. So user Lucas can read, is related to document secrets as read, is how you read it. But in this case, now I would have a concrete relationship here, but I wouldn't be able to delete still. If I would ask now, can user Lucas delete document secret? No, but I can read it. Now, role-based access control, which many are familiar with, is a subset of relation-based access control. So this is called, like, the first one is RBAC, and the second one is REBAC. I understand this can be a little bit confusing, but but REBAC is a relation-based access control, and we just added an E in between there. But again, the role-based access control can be modeled fully by in this graph. And how do you do that? So you start, for example, by some resource that you want to protect. Okay, so pods I want to protect. Then you make some roles that kind of bind to some kind of, anyone with this role, that is an assignee of this role, they should be able to get pods. Okay. And anyone with this role, called the leader, should be able, they have a delete relation with this resource. Fair enough. But how do we make users kind of bind to this? Well, we create some role binding. So we say that here is like a role binding of the leaders, and user Lucas is one of these assignees of the leaders binding, and they bind to this role. So this is how we can, and to note here is that we can have, there's many to many here, we can have many subjects on that one side, and we can have many roles on this side in kind of all aspects. And now if we evaluate that, can I do this? Can I get pods? We start from here. Yes, we have a get, evaluate this one, assignee, and end up at user Lucas. So we are authorized, allowed through, if we find a path in the graph for which the end is get between these two nodes. Now we know that we can do this, and likewise, if I want to know that can user Lucas delete resource pods, then OpenFGA translates, oh, yes, there was a path in that graph. Of course, now this is a graph where everyone can see it instantly, but there are real, like all the real world cases, they are real complicated. Nobody can see if that person actually can, do we get from here to here? You need a program for that. So this is how it would, for example, be modeled in the DSL. Don't need to spend too much time on kind of understanding the syntax of that. But essentially, we can say that, for example, there is the assignee relation between user and role binding is defined as this. So here is a target type, there is the subject type, the user, and through them assigning. But there are other ways as well. Those what I just covered are called, or we could call direct assignments, or they are the kind of what we actually store in the database. But sometimes, or very often indeed, we want to do some kind of rewrite, some kind of logic on top of this. So we don't want to write, for example, that. We want to have a policy such as if you can edit the document, then you can also view it. We don't want to have user Lucas view document secret and user Lucas edit document secret. We only want to have, in that case, for example, user Lucas edit document secret, and then the view would be inferred or implicit. This is one thing we can do. Again, there's nothing built into OpenFGA itself that would mandate this. This is something you define yourself in this declarative schema, which is very convenient. So that is one way to rewrite, and kind of at evaluation time, you will have kind of more these kind of permissions, for example, for a user than you would otherwise have. But this avoids if we would have two distinct roles in this table, that user Lucas view and edit, then what happens if I delete the view but still the edit is left, or vice versa. Then kind of data mismatch all over the place very easily. This avoids that kind of problem. Then we have inheritance, which is what I kind of started off by. So like if you can view the parent folder, then I can say that also you can view the folders, the folders recursively as well, but specifically, for example, then the documents in this folder. But of course, you don't have to do this. If you want, you can, but no must. And then set operations, the rest. So intersection, union, exclusion. What surprised me when I was reading the Google Zanzibar paper was that these are now like 5 primitive types. We have 5 ways of kind of defining the graph, all very, very kind of elementary operations. But still, I was surprised to kind of understand that Google actually managed to describe all of their authorization, logic and problem space using these seemingly simple things. So let's go on to RBAC and Kubernetes, the demo, the open source project I made. It's here if you want to take a look at the GitHub later. So in Kubernetes, we have API versions. So we specify groups such as apps or networking. This is, well, we started off without them, but then we realized we needed some to distinguish them. Then we have a V1 that also is good for, like evolving your schemas over time, so your clients can know how to read this object. Then we also are explicit with what type of object this is. Is a deployment or network policy or whatever. This also is very good, so you don't have to kind of rely on intrinsics. Then verbs, as with any REST API server, you would have get, post, put, patch, whatever. And Kubernetes API server is nice in the sense that it's fully uniform. I don't know what is the ratio of those that are versus those that aren't, but it makes it super easy to make a client to the Kubernetes API server because all of the paths are formed exactly the same way. So for example, if you want to create a deployment, then you do a post to apps v1 deployments. And here in red, I'm kind of using the verb or logical action that you're doing. Fair enough. So in the Kubernetes API server, how do we determine if an action should be allowed or not? Well, we have the authenticated user. So, and this data is very simple, just a username, a set of groups, and a UUID. That's how we determine that. And that we kind of get, because of course the authentication stage happens before the authorization stage, we already have all of these attributes. Then we know what API group are we talking about, what resource it is, deployments, for example, what are we doing to it, create, for example. And then optionally object name and namespace. And what is the output of the authorization process? It is either no opinion. That means that I don't have a data that suggests I should allow this thing, but because there are many authorizers in a row, Kubernetes is extensible, you can have 10 authorizers, and just if any of them gives you an allow, that's good. But also, so if you get no opinion from one, you just check the next one. Okay, so what do you think? Should I allow this or not? Only if we get deny, then it short circuits and denies. And of course, if you allow, then it's allowed. So role-based access control in Kubernetes, how does it look? This is defined using these resources. Here is a role. We say that anyone with this role, what can they do? They can get, list, watch deployments, for example. They can update deployment status. Fair enough. And here we say that, okay, so there's a user, Lucas, and a group team members. These are called subjects together. They should be bound to this role. Namespace is another thing, like serves as a logical isolation mechanism in Kubernetes for example, different teams. But that also works with this. And that would be called roles and role bindings. So that's just another type. So how do we map this to a graph? Okay, so we map each JSON kind of object, each API type, we map to one node at least. So here we have one node cluster role, reconcile deployments, assignee. Okay, that one. Anyone that is assignee of this role, they should be able to list, watch, get resource deployments here. But they should also be able to update this deployment status. So that's how, so this JSON object is projected into these so-called tuples, or these objects, edges and nodes in the graph. Then the cluster role binding, what happens with that? Well, we say that user Lucas and group team members, they should, well, be assignees of this. Okay, so that's why we start with defining those. And then we say that we bind these two together. So this role binding actually applies to this role, or this one. So now we have a full path in the graph between user Lucas and, for example, get resource pods. So now if we just, the problem of, when we have all of this data, the problem of authorizing just boils down to asking OpenFGA or another Zanzibar engine that is there a path in this graph? And this is a problem you can highly optimize for. It's another thing if you have in your API server code, a lot of if checks, which you will eventually, have one if check wrong, it's not auditable, and then things blow up. Of course, any system can blow up, but we try to make it harder with this one. So we have this project has two parts. One authorizer that actually just that hooks into Kubernetes API server, turns the Kubernetes API server requests into such a format that Kubernetes understands it's either allowed, no opinion, or denied. And then we have another part which takes data from different sources. Kubernetes API is one of them, but you can also take data from, for example, say your Keycloak or some other source of authentication and authorization info, and then project that, map that into the graph. So I made a controller which takes the role-based access control, the RBAC APIs of Kubernetes, maps those into the graph, and writes those to OpenFGA. So what does that look like? We have user Lucas. I'm trying to get deployments, my deployment. So now the authorizer will ask, can user Lucas access resource instance deployments, my deployment, as relation get? Well, let's see. Luckily, there's some kind of role in this system that says that anyone that has view all apps can get any resource in the app's API group. Luckily, I also happen to be bound to this role. Okay, great. But now we have a little bit of a problem. How do we kind of get from here to here? Because now at the moment, they are not connected. And this we solve by adding context. So the authorizer, when asking, when performing the check request to OpenFGA and asking OpenFGA about this, we can clearly say that although this was the only thing that was defined in the database, these never hit the database, we know from the context that clearly if we have star here, then this is one of the patterns that match this star. And we know that this is the one we're interested in because that's what we're asking now. So we can say that anyone that can get any of the resources in this group can get deployments. So if you manage to get here, you can get here. And if you manage to view all the deployments in this system, then you can also view specifically this one. So now adding the context in the check request gives us a full path in the graph. Similarly, if we would have a namespace and we would have say that, okay, team one, anyone in team one can view deploys in this team one namespace. They can view the deployments. And then I'm an assignee to this role. Then there's a path in the graph, but one thing we also have to take into account is that now I'm using this evaluation kind of mechanism is to say that both if I'm asking for something that is in the team one namespace, and I happen to have a role that kind of exists in that namespace, only then I can activate this, I can get here. If I'm in the same context as the role that kind of was specified for. And there's more of these. Kubernetes actually embeds one of these natively, so to say. So in order to prevent nodes from being overprivileged, for example, if someone would hack your node A, you don't want them to be able to access some certificate keys in a secret that only should be kind of viewed on a node B. And Kubernetes, there is a thing called node authorizer. It's a small graph engine written in Go, inline in the API server. But I wanted, this proof of concept, I wanted to show that, and the RBAC is as well authorizer of Kubernetes. I wanted to show that we can actually extend, and both of these concepts can be modeled with this Zanzibar approach. So, but why stop there? Although this is the thing that already exists in Kubernetes, it's great. But then we might want to have other things where we have these kind of graph-like relationships between objects in our API. And this is not only for Kubernetes. Think any cloud API or any API overall, you will have links between different API resources. And if you model them as a graph, then now you get the opportunity to start modeling the authorization state between these as a graph. Then we can do lots of kind of fine-grained things to provide you with an authorization state that actually should be and is not overly broad, which will eventually bite you. So I implemented this. I implemented both the RBAC and node authorizer with OpenFGA, supporting the existing kind of out-of-the-box functionality with Kubernetes. This showcases the extensibility of Kubernetes as well. And with this, we can now kind of prototype with new paradigms. So in practice, what does it look like? We have Kubernetes API server. It asks my extension, the reback authorizer, using a synchronous webhook, so just an HTTP call. Synchronous HTTP call. This reback authorizer sends further using gRPC to OpenFGA a check request that's asking, like, now, is this node connected with this node as this relation? Okay. And in order for OpenFGA to be able to provide some sensible answers to this, we also need to populate the data from somewhere, populate the graph of this data. So that's what's happening async. So I have a controller that reads RBAC information in Kubernetes or other API objects and project these kind of graph tuples into the OpenFGA graph. Unfortunately, as I said, I can't do the demo because it's streaming there. Here is otherwise like lots of documentation. I was bored on the plane to Chicago. But here we have the demo. Let's see. Oops. Not that one, of course. Fat finger. Let's see, Chrome. Hopefully I'm not, yeah, you can take it so I don't, I don't show any yle secrets.
You have already done it.
Yeah, maybe.
Back to the presentation.
I'll show the GitHub one.
Okay.
Yeah. Classic. Yeah. So I have so this is set up with three different users. Normal user, admin user, and a node user. And I'm starting off as the normal user. There's no data in here whatsoever. So then I would show that all of the kubectl get pods requests, they get denied. Okay, fair enough. Then I enter super user mode here. And I will now create one of these RBAC objects. I will say that anyone with the role view pods will be able to get list watch pods. Okay. I switch back to the normal user, and still I cannot get these pods because although I created a role, I created no binding to myself. So there is no connection. Then I go to the admin user again, but now I create a role binding between this role that I just created, view pods, and the user I am, normal user, and I just give it a name. So now that I go back to the context of a normal user, I will have all of these allowed. Then I go back to the cluster role, and I edit this list such that I remove the list and watch verbs. So I update the API object. It's already there in Kubernetes, but I update it now. So we need to, and this kind of shows that we need to be able to reconcile, just exactly as Minder did. We need to be able to reapply over and over again exactly the latest state, no matter who is messing with OpenFGA data themselves, or how the kind of desired state changes over time here. So I remove the list and watch verbs here. I go back, and I cannot get all of the pods anymore, but I can get specific pods. I can get specific pods in any namespace, but I cannot get pods and watch them. So that's the kind of RBAC demo. Now I have re-implemented the role-based access control of Kubernetes using a completely different thing. I deactivated all of the built-in stuff of Kubernetes. Then the node authorization demo is that I have a node user, so any node in the system this could represent. I try to do a bunch of GET requests. All of them fail. Then I switch to admin user, and I will create a node called foo node, a node object. I will create a pod hello, which runs on this foo node and references secrets, mission critical and very secret. And then, of course, I create the mission critical, secrets, and very secret. So no RBAC rules whatsoever. These are completely like just normal Kubernetes API objects. But as I said, the idea is that we take any type of data from anywhere. It can be a JSON object, it can be in Kubernetes, it can be in GitHub, it can be Keycloak, wherever. But as we have some authoritative source of data, now we project it into the graph. So when I've applied this, I didn't need to do anything else. I just switch back to the node user. I cannot get all of I cannot get all nodes because I shouldn't. I should only be able to see myself. To be frank, this is even better than the existing node authorizer. Any node can see all the nodes. Any node can also see all the pods. But that I also didn't feel for, so I denied that. And then, although we didn't specify any role or anything that says that, okay, foo node, I can see myself, and I can see the pod hello, which is running on kind of this node on myself, so to say. So I can see that as I traverse the graph. I cannot get all the secrets. I definitely shouldn't, because then the whole cluster would be pawned. But I can see the secrets which this pod that I can get reference in turn. So that's a demo, and there is, let's see, this one. Yeah, so here is I don't know how clearly it can be seen, but probably not too well. But just to show that I'm not cheating, here is how I run the API server that I'm showing. The only thing I had to do, so normally you have authorization mode, RBAC, and node, or node and RBAC in that order. But now I have none of them. Instead, I say that actually shoot all of these webhook requests to my authorizer binary that is here. So that's it. And there's so much to do still, of course. This is a demo. A proof of concept. It's a thing that is meant to showcase the kind of power of relation-based access control. This is just the beginning. Now there's lots of things going on with common expression language for also kind of ABAC style things. But also we could start doing the inverse thing. So I could say now, at the moment, I don't support this kind of show me all of the pods I have access to, for example. But that is such questions we can start answering in the future as well. So yeah, that's the presentation. Thank you.
All right, thanks, Lucas. Anyone who raises a hand will be authorized to use the mic. Jarno is the first one.
Thanks for the talk. How do you make sure that the model you write is the one you intended? Do you have ways to test the model? Or do you have ways to formally verify that it's what you want?
Yes, in OpenFGA and the other systems as well, you can, when you create the model, well, I mean, in one sense, you could mathematically also calculate all of these things, but for maybe normal user, you can write assertions to the server. So you can say that these are the kind of user Lucas should be able to get pods, for example. That should evaluate to true. But for example, these other things that I showed, a node should not be able to get all of the other pods or secrets, should evaluate to false. So those things you can write to the server. I'm not sure if the server, so you can the models, authorization models, the definition of the graph, they are immutable, but I don't know if I don't think that at the moment, if you apply a new one which would kind of make the assertion false, I don't think it would block it. But that is probably something that could be added in the future as a pre-flight check. Any other questions? There.
Great.
You have removed this RBAC and allowed only the reback or the server for checking, but what happens when that container which is authorizing it or accepting the request goes down?
Yes, so indeed, and that's what I kind of had this extensive list, and I would have written more if there would be space, but no. So again, like this is meant. So I highly appreciate if you have feedback or thoughts on this approach. Indeed, if it were to be implemented in like real life, I would probably write it into the Go API server. So again, today, all of the authorization modules in Kubernetes, they are written into the Kubernetes Go binary, the API server binary. So there is no need for any kind of HTTP request in between. But for that, so that would be eliminated. But then the question, like, if the API server would then still talk to the OpenFGA database or any other Zanzibar service and query the graph, of course, if you have no connection between the graph and your services, then there is different things you can do according to the CAP theorem, right? If you have if you have a partition, you can either sacrifice consistency or availability, and you would need to choose between those. But that goes for any system. But I think that like the idea of having this like, or it already exists in many other places, like a central authorization service. And there's always the problem of what if that goes down. I think one of the other projects, SpiceDB, does a really interesting thing where they have all of the kind of authorization server nodes in a ring, in a consistent hash ring, and then an SQL database behind that. But then when you ask one of them, it will kind of cache the sub problem to some degree, cache parts of that graph, and know also when there's new things coming. So it can give you actually a response kind of straight from memory. So if you would be running them together and kind of comprise the ring of, for example, 3 API servers, and on every of those nodes, you would have one of these SpiceDB servers forming a consistent string. I think that is one of the best things you can do.
Okay, yep. Thank you.
But unfortunately, I haven't solved the CAP theorem yet.
So no question, but can you show us the a snippet of your model?
Sorry?
Snippet of your model, like a definition, model definition in GitHub. Probably is there, but
actually, I generate the model from, or yeah, I can show.
I just wanted to check how extensive it is and how.
Oh yes.
This kind of
yes, I forgot to say. So the node is, I think, the best example. So it's this mapping between JSON object and graph is also declarative.
Okay.
So I would like to make it as a CRD, but now I made it into now it's just a Go struct. But I mean this also would suffice as a CRD. So how do we kind of map this node object down to the graph? Okay, so we have a type name, just a string. We call it core node, for example. How do we, from the node JSON, how do we extract the name, the unique identifier of this object? Well, in this case, we know that we can just take the name because that's already unique. Okay, so that's that kind of. So you return a string, and the node identifier together in the graph will be core node together with the ID of the object, the type and ID. And then what kind of incoming relations do we have? So we know that each node has there's kind of a user to node relation, where a user is called a kubelet, for example. That is coming from authentication stage. They should be able to access, so a user with name, using the Kubernetes convention, system node and the node name, should be able to access the node with the same name. So here we allow this user get user system node foo can get node foo, if that makes sense. And then we do the same for pod. So how do we extract the unique identifier of a pod? Well, that's the namespace and the name together, because name doesn't fully qualify it. What relations do we have between pods, or that involves pods? Well, we have a node to pod relation, because a node can point to a pod. So that's the relation node to pod between core node and core pod. How do we know from the pod object what node it runs on? Well, we check the spec node name. That's where it's defined. So we extract that out of this JSON file and return this string just as is. But then we also have, from this pod, we define outgoing relations. So pod to something. So pod to secret, we flat map all of the secret references in the spec. And then from there, we know that we need to be in the same namespace, but then the secret name there. And so on and so forth. And then we can say that if a node can, if someone can get a node that has this node to pod relationship, then they can also recursively kind of access myself. So these kind of recursive definitions could then, you can make as many as you want. And here we say that if you can get a pod that has a pod to secret access to a secret, then you can also get that secret, and so on and so forth. So this is one of the, I mean, this language is probably not too great, just the first thing I could come up with, but at least this framework allows you to map both all of the RBAC objects, they follow the same thing, and the node authorizer objects from JSON to the graph using the same consistent language. And these expressions could be using the common expression language, which is a declarative kind of this function mapping thing. So then from this schema, I actually generate the authorization model to OpenFGA, so there's no kind of step in between to do that.
Yes, thank you. Thank you.
Sorry, that was way too long of an answer.
Okay, do we have any more hands up?
Yeah, always looking for feedback. Let me know what you think about the approach. And yeah, come to our next meetups.
All right, thank you, Lucas. Let's give a big round of applause.
Thank you. And now we have networking until 9, right? Or what time is it? Yeah. Oh, okay. Okay. He says.
Yeah, I had to get my tickets, so I know what I must say. So first of all, I want to thank our great speakers. It was a lot of interesting topics, and thanks to you, the audience. You were great. You also laughed at the Kubernetes jokes, which was surprising. I didn't think those would work. I also want to thank the CNCF Foundation for co-hosting this with us, and special thanks to the Yle crew and Terhi for producing this. So let's give an applause for the crew. We have the space until, I think, for the next 30 minutes at least. So if you want to talk to people, please do. If you want to work at Yle, talk to people with Yle badges or the shirts. If you want to know more about that. Any food that's left, you can also take all of it. All right, that was it. Thank you.